We're learning how to divide polynomials with each other. So we're going to cover both ways of doing so long division and synthetic division. And in this video, we're going to cover all the bases or all the cases that you will need to know. Yeah, and it's a pretty long video, so please click on the timestamps to the one that applies to you. So hopefully you guys enjoy. Without further ado, let's begin. Okay, so this is just a standard polynomial here. No special cases. This is the normal version. So I'm going to teach you how to do long division for this. So over here, I've written out division, multiplication, subtraction, and bringing it down. So throughout this entire process, we're just going to be doing these four things, repeated over and over. So we'll see. So the first thing we do is we divide. All right, so what we divide is this term, the 3x to the 4, just this one, not the entire one, just the 3x to the 4, with the x over here. Yep, so just these two guys. So if we do that, we have 3x4 over x. From the exponent stuff, these have the same base, so we just subtract the exponents from each other. All right, so then we get 3x cubed. 4 minus 1 is 3. And then we take this and we put it up here. Awesome. So that's division. All right. So the next thing we do is multiplication. So what we multiply is we take what we put up here and we multiply by the entire divisor. So the x minus 2 here, the entire thing now. And where we put that is under here. So if we multiply 3x cubed with x minus 2, what we get is 3x to the 4 minus 6x cubed. Yep, and then we just put this result underneath 3. All right. So the next thing we do is we subtract. So what we do is we subtract this thing over here with this guy. So we subtract those two together. So I'm gonna put this minus sign. How we subtract them is just we need to take this term, the term up here, and subtract it with the term down here. So you have 3x to the 4 minus 3x to the 4, which is 0. We don't need to put anything if it's 0. And the next thing is we subtract our negative 2x cubed with our negative 6x cubed. So since we have negative 2 minus negative 6, what we'll have left is 4x cubed. Okay, so that's subtraction. The last thing we do is we bring down. So we have our 5x squared term over here. The next term in our long polynomial, what we do is just we bring it down. Plus 5x squared. Okay, so after this, we just repeat the entire process, but now we start with this term now. We start with this guy. So we'll kind of show the process of if you remember from before, when we divide, we only divide the front terms, so this first term here, and we divide it with x, just that guy, just those two. So we have 4x, okay, 4x cubed, divide by x, you get 4x squared. Yep, dividing exponents again, 3 minus 1 is 2. And then we put our result at the very top. The next thing we do is we multiply, and just like last time, we take what we put up here, which is the 4x squared, and we multiply it with the x minus 2. Okay, and then so we have 4x squared times x minus 2. from distributed property, 4x squared times x is 4x cubed. And then 4x squared times negative 2 is 8x squared. Okay. And then we take this result and we put it underneath. Yeah, it's a pretty long process over here. Okay, the next thing we do is we subtract. We subtract these guys together. So 4x cubed minus 4x cubed is 0. Since it's 0, we don't need to put anything here. And then 5x squared minus negative 8x squared. So since we have these two negatives, it becomes 5x squared plus 8x squared, which is 13x squared. Okay, and the last step is we bring down the negative x. So, as you can see, we're just moving along, and as we keep moving along, as we bring this stuff down, this is the last one we bring down, and then, yeah, we just keep going until we reach this term, and we can't do anything anymore, and then we'll have our results. Okay, so dividing, 13x squared divided by x is 13x. Okay, and then when we multiply, so 13x times x minus 2, 13x times x is 13x squared, and then 13x times negative 2 is negative 26. So 13x squared minus 26. Oh, forgot the x. Okay. Next step is subtraction. Is over here. So we just subtract these guys together. And then what we have here is negative x, well, 13x squared minus 13x squared is just 0. So we don't need to put anything here. And then negative x minus negative 26x. So we have positive 25x. Alright, last step is bring down. Okay, so since this is the last term, we just need to do this rotation one more time, and then we're done. We're going to have a quotient up here, the result, and we're going to have some remainder down here. You're going to see soon. Okay, so division. 25x, we take our first term, divided by x. X is crossed out, so all we are left with is 25. 25. And then we multiply. So 25 times x minus 2 is, we can write it over here, 25x minus 50. 25x minus 50. Okay. And then we subtract, so we subtract these guys together. 25x minus 25x is 0, so we don't need to put anything here. And then 1 minus negative 50 is 51. Okay. So, since we can't do anything anymore, we're done. And this is long division. So our result at the very top here, I'm going to use a little dot. I can't really see it. Okay, so the thing up here, this is called our quotient as a result of the very top up here. And the thing down here, the very thing we have at the very end over here, this purple one, it's called our remainder. So yeah, this is long division. And there's a couple of ways that you can write this out. In advanced functions for the first unit, we write it like this. So our polynomial that we originally started with is 3x to the 4 minus 2x cubed plus 5x squared minus x plus 1. So I'm going to write that out here. So 3, oops, thickness. So 3 is 4 minus 2x cubed plus x squared minus x plus 1. So we can write this out as, let me erase this. So our quotient, which is our green thing, 3x cubed plus 4x squared plus 13x plus 25 times our divisor, the thing we divided with, so x minus 2, plus the remainder we have down here, so plus 51. Awesome. Let's see, use these little dots here. All right, so that's it. That's basically long division. So yes, it's tedious. Yes, it's annoying, but hopefully the process makes sense. The biggest concern about this for me is making a subtraction or addition error. It's really, really easy. So yeah, be careful or watch out. It's really easy just to mess up on stuff like -2 minus -6, especially this part. The double negative stuff that happens here. So yeah, that's long division. Now here, I guess I'll just write this out. So this guy was our divisor. Over here. Wait, not our divisor, our quotient. And let's use orange for divisor. So then, yeah, you just do this. Quotient times your divisor plus your remainder. So let's say, let's pretend for, pretending's sake. At the end here, you get -51. So instead of plus 51, we're going to subtract 51. So just in case you guys get a remainder that's not positive, you can still write it out like this. It's just instead of you plus 51, you can write it as subtraction. So yeah, here we go. Okay, so in this example, it's a little bit different. So if you notice, in this case, our divisor has an extra term. It's not something simpler like x minus 3 or x plus 1. Now we have some weird quadratic thing. But the process is actually going to be very similar. It's going to be exactly the same thing. And actually, it actually takes less time if we have this, and you'll see why. Okay, so then we just have to put this into our long division, just like normal. So we have x cubed minus x squared. Shoot. Yeah, 6x squared plus 5x minus 4. Put that up here. And over here, we put our divisor plus 3. Okay, so hopefully we can still read my shoddy writing. So we have this. We still do our division. And yeah, just like before, we just divide the first term in our polynomial with the first term of the divisor. In this case, since our divisor is x squared minus x plus 3, we divide x cubed with x squared. So what we'll have is x at the very top. Next thing is we multiply. So we take what we have here, our x, and we multiply it with the entire divisor. Just multiply the whole thing, just like before. So negative x squared, x cubed. X times negative x is negative x squared. X times 3 is 3x. All right. Next thing we do is we subtract. So we just have to subtract these terms with these guys, the stuff that we got down here. X cubed minus x cubed is 0. Don't need to put anything here. And then negative 6x squared minus negative x squared gets us negative 5x squared. Okay. And then 5x minus 3x gets us 2x. All right, and the last step we do is we bring down, so we just bring down the negative 4. Okay, and then we repeat. So negative 5x squared divided with x squared from the very front is negative 5. Next step is multiplication. So negative 5 times x squared is negative 5x squared. And then negative 5 times negative x gets us positive 5x. And then negative 5 times 3 gets us 15. Okay. Next step is subtraction. So you just have to subtract these guys with these guys. So negative 5x squared minus negative 5x squared is 0. So don't have to put anything here. 2x minus 5x is negative 3x. And then negative 4 minus 50 gets us negative 19. So usually, at the very end, we stop when we always have a number here. But since we can't bring any more terms down, we actually stop here. And it makes sense because we actually can't divide negative 3x with x squared. We can, but we won't get something like this. We'll get a fraction. So we can actually stop here. So this is our remainder at the very end, is 0 quotient. And yes, our remainder can include variables like x. So let's put that here, 0 quotient. Our remainder is this, and our divisor is here. So when we're doing these long division things, the good thing to note is our remainder is always going to be 1 degree lower than our divisor. So remember from before, when you learn polynomials and characteristics of these guys, the degree of a polynomial is the highest number in standard form. So in this case, our divisor is degree 2, since the highest number is 2, and the degree of our remainder here is 1. There's actually an invisible 1 up here. So yeah, when we're doing a division, our remainder is always going to be 1 degree lower than our divisor. And we can write it out the same way as we did before. So we have, change this. We have, okay, here it is, x cubed, what did I do here? Okay, x cubed minus 6x squared plus 5x minus 4. This equals to our quotient, which is x minus 5, x squared minus x plus 3, which is our divisor. And then we put our remainder, minus 3x minus 19. So just like before, our quotient and our divisor. And then we add a remainder at the very end, 3x minus 19. Okay, so this is a special case where not all the terms are present in our polynomial. So if you kind of look at what we have here, we have negative 2x cubed plus 5x minus 8. So if you notice, we have a missing term here. We don't have an x squared term in our polynomial. So that part's missing. So the way we can divide this is just about the setup. That's the only thing that changes. So what we write here is you can write our normal polynomial. But then what we're going to do is we're going to add a placeholder term. We're going to add our x squared term, but since we technically don't have one, the coefficient at the very front of this term is going to be 0. Yep. So any terms that you're missing that you find in your polynomial, in this case it's our x squared term, we just need to put a placeholder term in our division thing. So in this case, our x squared term is missing, so we add 0x squared. So let's say, for example, if instead this is a 2, if it was this case, then our missing term would be x. So what you would do is in your long division, instead of having 0x squared, you have negative 2x cubed plus 5x squared plus 0x minus 8. So that's what you would do. Any term you're missing, you just add a placeholder. Okay. And then afterwards, we just proceed as normal. We just do our normal long division stuff. Yeah. So let's do it. So we have negative x cubed times, division, right. So the first thing we do is divide. Negative 2x cubed divided by x gives us negative 2x squared over here. Next step is multiplying. Negative 2x squared times x plus 1 will get us negative 2x cubed minus 2x squared. Alright, next thing we do is subtract. So negative 2x cubed minus negative 2x cubed is the same thing as negative x cubed, negative 2x cubed plus 2x cubed, so that gets a 0. We don't need to put anything here. And then we have 0x squared minus negative 2x squared, so that gives us positive 2x squared. Yeah. So notice nothing really changes even though it's 0. 0 is just a number, just like any other number. So you just perform our process the exact same way. Okay, so let's finish this. Next thing we do is we bring down 5x. Okay, and division, 2x squared divided by x gets us 2x. Next step is multiplying, so 2x times x plus 1 gets us 2x squared plus 2x. Okay. Next step is subtraction. So you just subtract these guys together. 2x squared minus 2x squared is 0x squared. We don't need to put anything here. 5x minus 2x gets us 3x. Okay, and then we bring down the 8. All right, last one. So division, repeat the process. 3x divided by x gets us 3. Next, that's multiplying. 3 times x plus 1 gets us 3x plus 3. Next step is subtraction. Subtract these guys together. 3x minus 3x gets us 0x, and then negative 8 minus positive 3 gets us negative 11. Sweet. So this is our quotient. Oh, shoot. This is our quotient. This is our remainder. This is our divisor. So the polynomial we started off with, we have negative 2x cubed plus 0x squared plus 5x minus 8. Oh, I guess we don't need it. Okay, let's scratch that. Let's start over. So how we can write this out at the very end is we have our normal original polynomial, negative 2x cubed plus 5x minus 8 equal to our quotient, which is the green thing, negative 2x squared plus 2x plus 3 times x plus 1, which is our divisor, and we add the remainder at the very end, so minus 11. Yeah. Okay, so yeah, same format. We have our quotient times our divisor, and then we add our remainder. Since it's negative in this case, we subtract it. There we go. So I'm going to show you how we can do long division for polynomials. We got our normal polynomial here, negative 2x cubed plus x squared minus 4x plus 1, and we're going to divide this by x minus 3. So the way we set this up is we're going to take all of these guys, the numbers in front of our terms, and we're going to put it on the top row over here. So you might be wondering, for this term, there's no number, so would it be 0 or would it be some other number? Well, in math, when we don't see a number in front of our variable, we always assume it's 1. So in our row over here, we are going to put the number 1. Okay, so negative 2, and then 1, negative 4, can make it bigger, negative 4, and 1. Okay, the next thing we do is we put our divisor, or this guy, on this side of our little synthetic division thing here. So since we have x minus 3 here, we actually don't put x minus 3 here. What we're going to do is we're going to take this number we see here, negative 3, and we're going to put over here, but instead of putting negative 3, we're going to put positive 3. So we just need to flip the sign. And this goes for any other synthetic division that you do. So 3. Okay. And we're almost done our setup here. The last thing we do is we bring this number down here, and we're going to start with negative 2 in the front. Okay, so as we do this, similar to long division, we are going to alternate between operations. In this case, we're going to be alternating between multiplication and addition of numbers. So to show you what that means, we'll just start doing it. Okay, so the very first step is we're going to multiply this number we have here, negative 2, with 3. So negative 2 times 3 is negative 6, and we put that number in the space below. Okay, the next thing we do is we add. So we're going to add 1 with negative 6, and that gives us negative 5. And we put that at the bottom here. So now we just repeat this process over and over again until we run out of numbers that we can bring down. As you can see, as we fill these numbers up in this row, as we keep going, we're gonna run out of numbers here, and then that's when we stop. Okay, so let's keep going. Negative 5 times 3 is negative 15. And then we add negative 4 plus negative 15 is negative 19. Then we go back to multiplication. Negative 19 times 3 is negative 57. Yeah, negative 57. And then 1 times negative 57 is negative 56. Okay, let me stop here. So you might be wondering what we're going to be doing with all of this. So actually, the last number that we have over here is going to be our remainder. So, like our normal division, we have the remainder. So this number right here is going to be the remainder of our polynomial right there. Okay, and then let's deal with these three numbers right here. So usually, when we do long division polynomials, our quotient is a bunch of numbers, kind of like what we have over here. Some with like x squares, x cubes, x. And then how we kind of use these numbers is, well, we're going to figure out what the highest degree term in our quotient is going to be. So degree is like the exponent on top of your variable. So since there's three numbers here, the number of the highest degree is going to be the number of numbers we see down here minus 1. So what that means is, since we have three numbers here, the highest degree of our quotient is going to be 2. Oh, oops, gotta change color. Okay. So we have x squared. Actually, I'm gonna write it somewhere else. Yeah. So our highest term of our degree of the term of our quotient is going to be x squared. Okay, and then this guy, the negative 2, this actually belongs as a coefficient of this. So this is going to be negative 2. Then afterwards, we just work our way down. So the next term is x, right? The one after x squared is x. So we have x. And then since the next number in our answer here is negative 5, that's going to be the coefficient in front of this number. So negative 5. And the last one is negative 19. Yep, so these three numbers here are just the coefficients of our quotients. Just like how when we set up our synthetic division, we put these coefficients or these numbers in front of our terms down here. So these numbers represent the numbers over here. And how we figure out, like, oh, what term do we start with? Is it going to be x to the 3, x to the 4? Well, we just have to take the number of numbers we see here, which is 3, minus 1. And the term we start with, the degree, is going to be the number of numbers we see here, minus 1. So in this case, 2. Okay, so we can write this to finish off. You can write this like how we usually do. So our dividend, or the polynomial we start off with, is negative x cubed plus x squared minus 4x plus 1. So we're going to write that over here. And that equals to our quotient, which is negative 2x squared minus 5x minus 19 times our divisor, which is x minus 3. And then we add a remainder, but since our remainder in this case is going to be negative, then we have negative minus 56. Okay, and we're done. And we don't have an x squared term here. It automatically goes to like negative 3x and then plus 5. So just like long division, what we do here for setup is we're going to put the coefficients in place. So these guys, we're going to put them down here still. But since we don't have an x squared term, we're still going to have a placeholder term. And since we don't have an x squared term, it's going to be 0. So our first number is 4, just like before. And the next one is technically our x squared term, but since we don't have it, we're going to put 0. And then -3, and then 5. Okay, and then everything kind of proceeds as normal. Nothing else really changes. The process is exactly the same. So the next thing we do for a setup is we put our number here, x plus 2. Technically, what we do is we take the number, the last number here, and plus 2. We change the sign to -2, and we put it over here. So we're going to do that. And then everything kind of repeats itself. So the first, we just keep alternating between multiplication and addition. Yep, let's bring this down. Okay, so then 4 times -2 gets us -8. And then 0 times 8 gets us 0. Wait, no, oops, we're adding. 0 plus -8 is -8. And then we repeat multiplication. -8 times -2 is +16. And then -3 plus 16 gets us 13. Then 13 times -2 gets us -26. And then 5 plus -26 gets us -21. Okay, so just like before, we have this as our remainder. And then we can write our quotient over here. So since we have 3 numbers over here, the highest degree term in our quotient is going to be x squared. So how we can write this up is we have 4x squared. Oops. I'm gonna change the thickness here. Okay. So we have 4x squared minus 8x plus 13. There we go. So let's write this out like our usual thing. So our polynomial we started off with was this guy, 4x cubed minus 3x plus 5. So let's write that down here. And that equals to our quotient, which is 4x squared minus 8x plus 13. And multiply this with our divisor, which is our x plus 2. So that is x plus 2. And then we add a remainder at the very end. But then since it's negative, we're going to write it as -21. And we are done. So if you notice in our long division here, we have a polynomial where our factor here is different from before. So if you remember, the number corresponding to this one would be 1/3. And usually we put that number over here. And you might be wondering, okay, even though it's 1/3, will it change anything? Like how's our synthetic division going to work? It's actually going to work the exact same way. We're just going to be working with fractions down here, and we'll have some fractions in our quotient and maybe our remainder. So let's see. Let's do this so you'll know what I mean. Okay, so the setup is the same. 1/3, -2, -5, -7, 3. Okay, bring down the 2. All right, 2 times 1/3 is 2/3. Put that over here. And then -5 plus 2/3. Quick mental math. -13/3. -13/3 times 1/3 is -13/9. And then -7 minus negative 13 over 9. So if we do this, negative 63 plus negative 13, negative 76. Negative 76 over 9. That's right. Is that right? Yes, it is. Okay. And then negative 76 divided by 9 times 1 over 3 is negative 76 over 27. And if you add these two up, we get 81. 5 over 27 as a remainder. Okay, so we got some funky business here. The math isn't very nice at all, but it's still okay. The process is the same. Just have to get used to working with some fractions. And then we still write out the same way. So since we have three numbers here, the first term we start off with is going to be x squared with the 2 in the front. So 2x squared minus 13 over 3 x minus 76 over 9. That is our quotient, and our remainder is going to be 5 over 27. So if you don't like the fractions over here, what you can do is you can factor out the lowest common denominator. So in this case, it's 9. So because we're dividing by 9 for this fraction, we're actually going to factor out 1 over 9 out of this entire quotient. And that way it's going to leave us with some whole numbers here, and it's going to look a little bit nicer. So for factoring out 1 over 9, we just need to divide each one of these terms by 1 over 9. And in this case, it'll just be the coefficients. So first start, 2 divided by 1 over 9 is the same as 2 times 9. So we get 18x squared. And then you can check if you did this right. If you FOIL the 1 over 9 back in, or if you distribute the 1 over 9 back in, you get 2x squared. So we're doing this right so far. Okay, and then 13 over 3 divided by 9. 1 over 9 is the same as 13 over 3 times 9. So we get, actually, let's do this by hand, not to mess this up. So these guys cancel each other out. And then we have 13 times 3. So you're confused about this 1 over 9. We technically did this. Right, we divided 13 over 3 by 1 over 9. Okay. Then we have 39. And then 76, well, divided by 1 over 9. This one's nice because we're factoring out 1 over 9. We just have negative 76. Awesome. So let's put this into our quotient form, or writing it out in our quotient form. Okay. So let's erase this stuff just to get some more room. Minus 7x plus 3. So you can write this as our quotient, which is this guy over here, our quotient, times our factor over here, this guy, plus the remainder. So you can write it out the same way. Oh, I actually erased the 1 over 9 here. Okay, so 1 over 9, 18x squared minus 39x minus 76, 3x minus 1 plus 5 over 27. And we are done. So we didn't really cover this, but we didn't really talk about when to use long division and synthetic. Both work. They'll get you the exact same answer. But basically, what I suggest is always use synthetic because it's just much faster than long division. As you can see from the video, it took us quite a bit of time to do long division, and it's a lot of extra steps. Synthetic division is much easier once you get the hang of it. The only drawback for synthetic division is that it doesn't work all the time. It only works when your divisor is degree 1. So for example, let's say you have some random polynomial thing. So x doesn't really matter. Cube minus 5x squared plus 8x minus 6. And you're dividing by x squared minus 5x plus 1. Okay. So let's say your job is to divide these two guys together. So you can't use synthetic division here because our divisor, or this guy here, is not degree 1. It's degree 2 because of your exponent here. Saying goes that this should change to 3 or change to 4. You can use long division for this. Long division will work for any single case, but you can't use synthetic. So yeah, your synthetic cases will only work if your divisor here is degree 1. So stuff like 3x plus 1, or like 2x minus 4, like x plus 8, like 10x minus 1000. Sure, why not? Yeah, synthetic division works for all the cases where it's degree 1, but not if it's degree 2 or more. So yeah.